They're not the majority, but they're still out there.
So once we got to geometry, I'd like start crying in front of the students, and that'd be really embarrassing.
Did I think I would ever be teaching calculus 2?
Oh, no.
No, I did not. I would have laughed you off the planet. I know. And you think there's not to be a doctor?
Oh, well.
Okay, so tell me where you, at what point you stopped being confident that you were right.
It was, the whole thing was like multiplied by the
Mhm,
3,125 times. It was 1/3 times the square root of x squared minus 25 over 5 cubed
Mhm.
plus 1/5 times x squared minus 25 over 5 to the 5th.
What's the constant?
Yeah.
Okay, see if this is equivalent to what you said. I think I wrote a couple things differently. Instead of square root, I have x squared minus 25 to the 3/2, but you said square root and then you said cube, so I think that would be the same.
Yes.
And then you said 5 cubed in the denominator, and then 1/3 of that, I just have 375. And then you have x squared minus 25 to the 5/2, and 625. So I think that's equivalent to what you said.
I believe so.
Okay. 375. I multiplied, you said 5 cubed times 3. That's 125 times 3. That's 375. Yeah. Okay, what is, let's see. We would be factoring out the LCM of 625 and 375, the smallest thing that they would both go into. Tell me what 3,000, just punch on the calculator for me, what's 3,125 times 15? Punch, yes, 3,125 times 15.
46,000.
Oh yeah, I count that. I count that 100% right. But tell me again. No, tell me that big 40,000 number you just said.
46,870.
All right. That must be the smallest thing these two will both go into, because this reduces to 1/15. Oh, 100%, being as I just got that number from telling you to multiply. And then the x squared minus 25 to the lowest exponent would be 3/2. And then if you divide 375 by 46,875 divided by 375, I think that comes out to be 125. Punch it and see. That denominator divided by 375.
Yeah.
So yeah, you had to factor out a 1 over 46,875. Yeah. And then 2 more steps and you'll have it.
On number 7, I don't usually do the problem,
Okay.
but it's got like natural log of a binomial and both are over 5.
And
And then the final answer just takes away those 5s.
it's with a different constant.
Oh, cool.
Yeah, because the natural log of 1/5, the natural log of 1/5 would be a constant. And so you could, when you have natural log of, let me write it this way, 1/5, natural log of 1/5 times, parentheses there, x plus square root of x squared minus 25. Do you agree that that's the same thing? And then when you have a log of a product, which is what this is, you can rewrite it as the sum of 2 logs. I know, that upsets me too. And that's equivalent, and then that's just a constant. So if this was plus 1 constant, then this would be absolute value plus some other constant. I love that.
They're all erasable.
What?
You just love technology. This is what the future is.
What?
Erase
More
with
than
pens.
one.
And I wouldn't have to have whiteout tape?
I'll get you those for your birthday, Miss Smile.
That's February.
That's okay.
What?
They erase really well. They're not like garbage.
You should open things on
Like the
garbage.
clear part.
Oh, I've seen these before. Okay, but so you just have to. Okay. And then him that's smarter than me. I don't want to break it, but it's not.
Put it down.
I've never seen that before.
What'd you get?
And
And
and that's actually an eraser on the top. Okay. Yeah, it doesn't write. Well, maybe. It doesn't write beautifully, but it does erase. So there's a priority thing going on there. What's more important, to write beautifully with good ink or be able to erase?
Well, when you're doing math, be able to erase.
No, I got whiteout tape.
That's true.
I'm all about smooth ink.
But it was
Yes, it was. Oh, and I didn't bring it today, so I better not mess up. Okay, any other questions from the homework?
number 5.
Number 5.
I got to the interval part where it was like 4 integration of cosine squared over sine squared.
Okay,
Or sine not squared.
yes.
So I took that and I put it into cosecant times cotangent.
I have something that might be easier than
I saw
that.
what they did, but is that legal?
Let me write down the last thing that you agreed with. You had that.
Yes.
And then you did what?
4 integration of cosecant times cotangent.
You went from here to that in one step? Oh, y'all just amaze me. So what you did is write that as 1 over sine theta times, I see why what you said is not legal, and maybe you shouldn't do it in one step. Did you write it as 1 over sine times cosine over sine? That's what would give you cosecant cotangent. Is that what you said? And you see why it doesn't work? Yeah. Well, yes, that would be cosecant cosine, and that wouldn't do you any good. You were splitting that apart as if you had addition and you had to keep a common denominator in both. So maybe don't do it in your head. That's why I don't do it in my head. I do goofy things like that if I don't change it to sine and cosine. All right. Anything else?
Like I have the answer, but there was just like a 2 somewhere that I didn't have.
And then you add 2. That's the last step.
But it would be like in the argument or something.
Okay, here's what you have to do. I mean, for us to work this out, you've got to send me pictures of it so that I can look at it and get back with you, like you did the other day. You sent me a picture the other day, and I went, well, look, you see, blah, blah, blah. So anything that you don't have the exact same answer in the back of the book, and you're not positive that your answer is equivalent to their answer, you need to take a picture and send it to me. So I can go, yes, I'd give you full credit for that on the test, or, ooh, here's something you're overlooking. Watch out for this because you don't want to do this on the test. Anything else? Okay. Yeah, maybe you're smarter than your friend. Tell her I said that. Okay. Miss Samantha, had the inkling of how they were choosing what to use as a substitution yesterday. And did that firm up in your homework last night? Did you got pretty good?
Plus sign, it's tangent.
Okay.
And it depends if X are first or second.
The U or the A. Yeah, the U or the A. And some of y'all, I don't think will end up needing to do what I do, but I don't memorize and I don't keep things in my head. I learn how to, or I understand how to do something and draw myself pictures and write myself notes at the top of the paper before I start taking the test. Otherwise, I forget it. Memorization just doesn't work for me. So here's how I develop the 3 things that I put at the top of my test to determine, to have these 3 triangles at the top of my test so I can look at them and figure out which trig substitution to use without having to memorize anything or sit there and squint until I get more wrinkles on my forehead. Exploration 2. Label a right triangle such that sine of theta is u over a. The 3 trig substitutions we used yesterday all involved either sine or tangent or secant. So those are the 3 triangles we want to label. Label the first one, sine of theta is u over a. If we call this theta, then opposite has to be u, and adjacent hypotenuse has to be a. And so what's the adjacent side? Mm-hmm. Oh, I'm sorry. Tell me. Tell me. Just put that down and zoom out just a notch. So, when I have a square root of constant squared minus function squared, a is a constant, use a function. So if I have square root of constant squared minus function squared, then I'm going to use, right here, sine of theta is u over a. For my substitution, I need to use u equals a sine theta. Just take that, clear out the fractions. And that's what I'll use for a substitution. That's what was given to me yesterday. Cheryl's so happy. Okay, so let's do the same thing for a trigonometric substitution involving tangent. If we have some angle theta, and we label it in such a way that tangent theta is u over a, that means opposite is u, adjacent is a, and hypotenuse is what? And order doesn't matter with addition, so it could be u squared plus a squared, or it could be a squared plus u squared. But whenever I see that, I'm thinking tangent theta is u over a, so u is a times tangent theta. And Cheryl, you were saying I'm pretty sure about everything except for the coefficient. The coefficient's just a, which will be the square root of the constant in that radical expression. All right, so one more triangle. Label a right triangle such that secant theta equals u over a. So here's theta. Secant's 1 over cosine, and so it's hypotenuse over adjacent. Hypotenuse must be u, adjacent must be a, and what is the opposite side? And so when I have a radical in the form function squared minus constant squared, then what trig substitution am I going to use? U equals a secant theta. And so what's still the hardest thing, and seriously, I memorize it before the test, I write it down on my paper at the top of the test, and then I forget it the next day. That's because I'm 53, you're 19, you may not have to do that, or 17, whatever. I still forget my arcsine and my arctangent formulas. Forget what gives me arcsine and what gives me arctangent. No, I remember tangent. Arcsine and arcsecant are the two that I keep forgetting. Does anybody have a cool? I can remember that arcsecant is the one that has a u in front of the radical. I need to remember that arctangent looks just like arcsecant as far as coefficient of 1 over a, argument of u over a. And arcsine just doesn't have that coefficient. I'm not sure that'll stick though. You don't have a cool way? Yes. Okay. Somebody comes up with a cool way. That's a good honors project. No. No, it's not. Okay. So, at the top of whatever integration test I'm going to be taking, how to, I write those three formulas, otherwise I forget them, and I draw these three triangles. I don't need to write any of that. I just need to look at my three triangles. So on the back of that page, or the front of the next page, I have exactly what's at the top of my test. Those three formulas and those three triangles. Now we're going to do one problem before we get to this number 22. After 3 or 4 problems, I probably don't need to write all of that down anymore. But in order to be able to teach this for the first time last year, I had to have steps. So I'm a step-by-step kind of person. So let's do one problem that's just a tiny bit easier than this one, and then we'll go through these steps that I believe will work on every problem. Number 20 is the one I want to start with. Page something. Number 20. Yes. All right, here's the problem. Is that square root of a squared minus u squared, or u squared minus a squared? U is a function, a is a constant. So in this case, u is x, and a is 2. Now, some of you may automatically go, and I remember which substitution that is. I don't remember what substitution that is, but I have this at the top of my paper. And I go, which one is square root of u squared minus a squared? That's secant. So the substitution that I'm going to use is u is a times secant theta. Yes, ma'am.
Is the argument ever going to be like 4
I bet one of my examples has that. I think it will. When we do a u substitution, we'll have to come up with some other letters, but hang on. If that happens, I have one circle to do right off the top of my head. I don't see where that happened, but we'll deal with it if it comes up. Okay, so since I have u is x in this radical expression, and u is 2 secant x in this trigonometric substitution, then really I have x equals 2 secant theta. That's the substitution I'm going to use. And, well, I'll say that's what happens. Okay, that's x, so what's dx? 2 secant theta tangent theta, what else? D theta. And then also, I suspect at some point, I'm going to need this triangle with some angle theta labeled in such a way that secant is x over 2. If I solve this for secant, I'd have x over 2. And if secant's x over 2, then hypotenuse is x and adjacent's 2. So I have cosine would be 2 over x, so secant would be x over 2. That's right. And here's my square root of x squared minus 4. All right, that's everything we need. Let's rewrite that integral in terms of secants and tangents. Well, actually, yesterday I kind of went out to the side to develop the square root of x squared minus 4. I can still do that out to the side, or in the body of the work I can say if x is 2 secant theta, then x squared is 2 secant theta squared, and then minus 4. And then, what's easy to forget in this process? The d theta, or the dx. I need to put all of this in place of dx. So I'll put the 2 secant theta tangent theta in the numerator. And the d theta where I'm used to seeing it. Then let's use all of our trig skills to clean that up. Actually, there's no trig skills here. It's just canceling common factors. I'm not going to do anything in the numerator yet. That denominator is 4 secant squared theta minus 4. I can see if I factor out a 4, I'm just going to have a 1 minus secant squared. And the more you do this, the more... Secant squared minus 1. Yes. Secant squared minus 1. And secant squared minus 1 is what? Tangent squared. So the more of this you do, the more steps you are able to skip. That's 2 secant theta tangent theta over the square root of 4 tangent squared theta. That's just 2 tangent theta. And I think what I just said was wrong and what I wrote was right. No. Was it? Good. Y'all stop listening to me. Y'all stop listening to me. That's a good thing.
No. Stop listening to me. It's something my mom said. Stop listening to me.
So the thing we're integrating here, secant x d theta. How about that? Yes, the deeper you go into math and you realize that natural log has anything to do with trigonometry, or that E has anything to do with trigonometry, the hyperbolic functions, you've got trigonometric functions whose definitions are exponential functions. It's crazy. It's crazy. Crazy fun. Okay, is that our answer? No, it's not. In place of those thetas, we have to put what?
Do the triangle.
And I've done it up here. So I have my angle, I have my triangle. I just, yes, I can't. It's got to be parallel to the side because I'm on CD. What will I put in the place of secant theta? Secant is 1 over cosine. Cosine would be 2 over x. So secant would be x over 2. And what do I put in place of tangent? No, they will not just say that 2 doesn't exist.
Yes, they will.
Let me show you. Let's call this, I'm going to count that right on the test. That's perfectly fine. But I want to show you why the 2 never disappears. Right. But I don't remember if Jordan was in here when I did that a minute ago. Let's play like that's not up in the air because I factored out the 1/2. All right. All I did was factor a 1/2 out of those 2 expressions. And then you're absolutely right. I can't take natural log of that expression, or factor by factor, expression by expression. But I can say that's a product, and the natural log of a product can be written as the sum of 2 logs. So far, so good. Jordan, were you in here when I did this a minute ago? Oh, okay. I just couldn't remember. And then the natural log of a 1/2 is a constant. So just the logarithmic expression plus a different constant would be equivalent. But as far as what's right on the test, that's fine, or that's fine.
But my question is, why do you keep it constant that you do the recursion for a constant? What's the difference?
Okay, let me. No. I know the answer, and I'm trying to put it into words. It's not that you have a constant that you do know and a constant that you don't know. It's here you have 2 constants. Here you only have 1 constant. So 1 constant is simpler than 2 constants, even though this constant is a portion of this constant. Remember what's coming in DE is I'm going to give you an integral, and I'm going to give you some initial condition, and you're going to use the initial condition to find out what that constant is. Well, it would be easier to find this constant than have to do both of those things. If I was working backwards, if I didn't know that, I could find the constant using this expression rather than that expression, and it would be just a tiny bit simpler. All right. Now, let's go to my pretty steps. What I'm all about. The pretty steps are not going to be on the test. Actually, I think y'all have this. It's just a matter of cleaning up ugly things. I think you got the process totally. But the first time I taught this, it was all very messed up in my head, and I was having a difficult time conveying to my class, here's what you need to do that works every time. So these steps are what I came up with that works for me. And like I said, maybe you don't need them already, but if you do need them, then keep this paper beside you the first few homework problems you do, and then put it aside, see if you can do it without these. All right, there's my radical part, and is it of the form a squared plus u squared, a squared minus u squared, or u squared minus a squared? Well, it's plus, and with plus, order doesn't matter, but it looks like in that radical expression, u would be what? 5x, and a would be 2. All right? So when I have a u squared plus an a squared, or an a squared plus a u squared, that one I can remember without looking at the triangle. It's always tangent, but I have the triangle up there if I need it. So the trig value to be used for substitution, u is going to be a, which is 2, tangent theta. All right, since I have u equals 5x and I have u equals 2 tangent theta, I can just set those two expressions for u equal to each other, and I'll have my substitution that I use for x. 5x equals 2 tangent theta means I'm going to put what in the place of x? Or I'll just write it 2/5 tangent theta. So far, so good. All right. If x is 2/5 tangent theta, then what's dx? Good. 2/5 secant squared theta d theta. Then I'm going to come up with a way to write that square root of 25x squared plus 4 in terms of this. So I'm going to start with the square root of 25x squared plus 4. And in place of that x, I'm going to put a 2/5 secant squared theta. No, I'm sorry, I was looking at dx. Just kidding. In place of the x, I'm going to put 2/5 tangent theta. And it's squared. That's just 25x squared plus 4. And what all cool things happen there? The 2/5 squared is 4 25ths, so the 25s are going to cancel. If I don't feel like doing anything else in my head, I'm just going to say that is 4 tangent squared theta plus 4, square root of all that. And then I realize I can factor out a 4, and that'll leave me 1 plus tangent squared plus 1 plus tangent squared. Secant squared. And then what's the square root of 4 secant squared theta? Yay. And then it's time to rewrite the integrand in terms of theta instead of terms of x. Okay. The numerator is just what? 2 secant theta. And the denominator is what? Right. 2/5 tangent theta to the 4th. And don't forget the dx is, it would have helped if I had written dx equals right there beside it where I could see it, instead of having to look all the way across the paper. Dx is 2/5 secant squared theta. I'm just going to put that 2/5 Hold on here. 2/5 secant square theta in the numerator with the d theta out to the side. That's a little bit ugly to clean up. That's probably true. We probably have. Let's see. Actually, for those coefficients, I grab scratch paper and work it out. I say that numerator is 4/5 secant cubed theta. And you won't see these steps in the book. They'll take a giant step from this to what the simplified form of the they're assuming that you're good with fractions by now. And we are. It's okay. So that's 4/5 secant cubed theta over 16 over 625 tangent to the 4th theta, d theta. And here's where scratch paper comes into play. 4/5, or here's where calculator comes into play. Work without the calculator. Look at this. This is 4/5 times 625 over 16. My brother can do it in his head. Yay, I graduated sooner than Lottie, who barely graduated. 5 goes into 625. 125 times, 4 goes into 16 4 times. That's all that will simplify. So finally, we have a constant we can bring out front. 125 over 4. And then if you can simplify secant cubed over tangent to the 4th in your head, yay, more power to you. I have to say secant cubed is 1 over cosine cubed, and tangent to the 4th is sine to the 4th over tangent to the 4th, over cosine to the 4th. Let me double check that, because all of a sudden I don't remember having a cosine to the 7th in the denominator, but I may have. Let me just double check. Tangent to the 4th is sine to the 4th over cosine 4th. Secant cubed is 1 over cosine cubed. So maybe I just forgot about this to the 7th. Where do I have this all worked out? I see what I did. Do you see what I did? What did I do, Michaela? Yeah, you're dividing by tangent, and that's the same as multiplying by cotangent. All right, so I ran out of whiteout tape last night. Gonna stop it. The other 300. This should be cosine to the 4th in the numerator and sine to the 4th in the denominator, because we're dividing by tangent. Gosh darn it. That's what I remember coming up with yesterday. So that's 125 over 4. And what does that integrand simplify to? Okay. And how is that helpful? Sine's the negative 4th, but yes. Yeah, if I have 125 over 4, and then I look at that integrand as being sine of theta to the negative 4, then cosine of theta is the derivative of sine theta And that's exactly what I need. Let's check it. If I take the derivative of sine, do I get a cosine? Yes. So I don't need a negative. But I always have to check it. I'm never sure about SIGN until I check it. So what is the antiderivative? Oh, look, I didn't align this from last night. Integrate, what's the antiderivative of sine theta to the negative 4? Sine theta to the negative, what did you say? Yeah, add 1 to the exponent, you get negative 3. Divide by the exponent, you get negative 1/3. Double check it every step of the way. I know I've got a plus a constant, but I'm checking one other thing here. If I check this, the negative 3 times the negative 1/3 would give me back the positive 125 over 4. Then I'd have sine theta to the negative 4, and I'd have cosine theta beside it. And that's exactly what I had on the, or equivalent to what I had on the previous line. So I'm ready for my plus a constant. And I'll call that, in simplest form before back substitution, negative 125 over 12 sine cubed theta plus a constant. So on the test, that's 1 point. That was a joke. That's about 3 points. Other 2 points, we're going to have to get that back in terms of x instead of theta. So I'm going to look at this trig substitution that I made in part B, and I'm going to say if u is 2 tangent theta, I want to label my triangle in such a way that tangent theta is u over 2. So here's my triangle. It's an angle theta, labeled in such a way that opposite is u and adjacent is 2, and hypotenuse is square root of, I need to label it 5x instead of u, because u is 5x. Square root of 25x squared plus 4. And all I need from that triangle is sine. So sine theta is opposite over hypotenuse that's what I'm going to put where I have a sine theta. Anything, Michelle? Okay. I'm gonna, since I'm dividing by a fraction, I'm gonna flip that fraction, and I'm gonna say when I bring the 25x to the 4th plus 4 to the numerator, what will its exponent be? 3 halves, because it's square root raised to the 3rd power. In the denominator, I'll still have the 12, and the 5x is still cubed. Ooh, guess what that's going to take care of? 5 cubed is 125. So negative. Am I right? Why did I start writing x to the 4th right there? There's no reason. No reason. It's a typo. Negative 25x squared plus 4 to the 3 halves over 12x cubed plus a constant. This is going down in my book as one of those things that isn't as difficult as it is tedious. It's very tedious. And there is no way, without trig substitution, that I could have integrated this and had any idea that it was going to be that. Pretty cool. All right. We're not going to have time to do all the examples that I wanted to do, so let me skip to something that's a little bit different. I think I solved, there was one that was integration by parts. Good. Good. What about integration by parts twice?
Yeah.
That's about where I want to hang myself. That's only funny if you know I'm not really suicidal. Otherwise, you call 911 for me. Number 26, I'm not going to do it, so don't write it down. The only thing that makes 26 a little bit uglier is A is going to be what? Yeah, that's a kind of a pain, but okay, we can handle irrational numbers. I'd rather have an irrational number than an irrational person. Yeah, we've dealt with that before. 28 is not significantly different. Look, 28 is interesting in that A is 1, and what is U? Yeah, U has to be the square root of X.
This is just algebra. This is very hard algebra homework is what this is.
So if you write U is square root of X and A is 1, then that's the square root of A squared minus U squared. And that's the only part that's hard to get. So that was 28, and I had 2 other circles. Yeah, let's try to get both of these done. That's not bad. I don't see one. I know you were hoping for that level of ugly.
I just go like that in my homework and go.
Yeah, I don't see. Look at all the. What that would take, Samantha, is instead of an x squared or instead of a monomial squared, if you had a binomial squared. And you know what? If I had a binomial squared, I'd FOIL it out, add 3, and wouldn't have a binomial squared anymore. I don't see anywhere that that's going to happen.
Okay.
If it does, we'll you send me a picture of it so I can look at it before next class. 30. 30 and 32 are the 2 that I would like to try to get done. Because 30 doesn't even look like it belongs in this section.
And the cats, and they just let them step all over the calculator, and they make us solve.
How'd you know?
Michaela and me would have loved that cat metaphor. Me too.
We're just going to make a big raisin that's like roasted with some Halo, and that's going to be your Halloween decoration.
Okay. I don't see what that has to do with trigonometric substitution at all. So let's play like we don't know it's going to be. We'll play like we don't know it's in section 8.4 and try something else. Okay. That's ringing the bell. If we let the denominator be U, then what's du? Do we have anything close to that, or any way we could get that in the numerator? And what can you do with it? Well, if you have an erasable ink pen, we can get rid of it. What about break it into two integrals? Just make the one part of a different integral. Is that legal? It's what we just separate it and we'll worry about it later. It works. It works for immigration. It works for calculus. Okay. You're the only one that thought that was funny. Okay. So here's what we're thinking. We don't know it's going to work, but we're going to try x cubed plus x in one integral numerator, and we're going to try 1 over x to the 4th plus 2x squared plus 1 dx. Is that equivalent to the line above it? Then it's legal. All right, what's your next thought? I need a 4 in the numerator. Well, I can do that if what? Okay. So I'm going to go ahead and put that here, and here, and here. Is that still equivalent to the line above it? Yes, it is. Since the numerator is the derivative of the denominator, that integral is natural log of the denominator. Nope. Maybe there's a reason it's in section 8.4. Yes, it is. Yes, it is. So, Michelle just figured out that denominator is x squared plus 1 squared. And we're through with the first term. But the second term, tell me what you think of. But it doesn't have tangent, then you wouldn't have that square outside. All right. Yeah. I was overthinking anything.
It's not working.
I would love for it to be arctangent, but it's not.
Be nice.
I don't know how I feel about it. Well, I don't see the problem with the same thing squared and not 4 plus x squared. Maybe it's
Yeah, let's go ahead and, because it's a squared plus u squared, I know to use tangent. If I didn't, I'd look at my rectangles real quickly and say which one has a u squared plus a squared, and then I would see that that's tangent. Right there. So if I let u be what? X, and a be 1, then something else I'm thinking. Oh, I figured out that the trig substitution I want is u equals a, which is 1, tangent theta.
That's
And if u is 1 tangent theta and u is x, then x is 1 tangent theta. And I'll stop writing that one at some point. If that is x, then what's dx? Secant squared theta d theta. Do I need anything else before I substitute? think so. I could get the x squared plus 1. Let's see. X squared plus 1 would be, I'm going to go ahead and do the whole denominator. X squared plus 1 squared. X squared plus 1 would be tangent squared. Ooh, it'd actually be, yeah, tangent squared plus 1 squared, better known as secant squared. Ooh, I lost my theta. Alright, that's the whole denominator. So, don't lose the left half of this problem. Rewrite the integrand as what? Okay, dx is secant squared theta. Put the d theta out to the side. And the denominator is just what? Secant to the fourth theta. Yeah, 1 over secant squared is just cosine squared. And we do have a formula for that. I don't know why that dx kept coming down on the left-hand side after I integrated. That formula for cosine squared is theta. I'm going to put it over here. Cosine squared. This is the formula I'll give you on the test. It's 1 plus cosine 2 theta. No, it's oh, that's after I integrated. Tell me what it is. 1 plus what?
2 sine 2 theta.
All right. So what I always do with that is bring the 1/2 out in front of the integral, and then I'm just integrating 1 plus cosine 2 theta d theta. There's still a problem. It's not a big problem. Yeah, it's, I remember. I can take the antiderivative of 1, it's just theta. But to take the antiderivative of cosine 2 theta d theta, I have to have what with the d theta? Yeah. Which means I have to have a 1/2 in front of that integral. I haven't integrated yet. I've just got this in a form that I could integrate. I took the antiderivative of 1 is just theta. But then I'm thinking if I'm going to integrate this term by term, then I'm going to have cosine 2 theta with a 2d theta. I didn't have a 2d theta, so I put a 1/2 out front. So, I'm going to go ahead and distribute that 1/2. And then what's the antiderivative of cosine 2 theta? And that's all well and good, except for I don't have a triangle with an angle named 2 theta. I just have a triangle with an angle named theta. I'm going to take this to scale prefactors again.
It was really fun.
What is sine of 2 theta? 2 sine theta cosine theta. And that 2 times 1/4 is 1/2. And then what I don't have time to finish is the back substitution, but it's just a matter of cleaning the teeth at this point. We're gonna, I'll draw the triangle and then I'm gonna run teach college algebra. If u is tangent theta, then theta, no, that's not what I want. If tangent theta equals x, right here, if tangent theta equals x, how do I label my triangle? Opposite is x, adjacent is 1, and hypotenuse, if I need it, is, yep. Now all I need from that is sine and cosine to substitute right here and clean up as much as I can. All right, the one that I didn't get to do, and maybe there's an example like it in the book, or maybe you'll look at CalcCat, or maybe you'll ask me Monday. Any one of those things is okay. But number 32 is kind of like number 30 in that it doesn't look like something that you would use trigonometric substitution on. It looks like something you'd use integration by parts on. And after you use integration by parts, you might get something that you have to use trigonometric substitution on. All right, have a great fall break. I wish I could say you have 5 days, you don't have to do calculus, but that is not true. You have 5 days to do all the calculus you can do.
Is there like a big meeting going on here, man? Because that's what my physics and statics teacher told me. He had to cancel class that Wednesday we come back because he said like.
Oh yes, yes.
So like people are coming in to evaluate or something.
Yes. The